Let us now look at a new technique for projection of lines, and this is called the plane rotation method. So there are some advantages of using plane rotation method over the line rotation method. The first and foremost advantage is that it's conceptually much easier to visualize, and number two, it is simple to construct. So let's how the method looks like. What you see on screen is the representation of this plane rotation method, and we'll start animating this picture. And if you see here, the line AB is a line which is inclined to both the vertical and horizontal planes. So as usual, our aim here is to find the projection of the line AB on the vertical plane as well as the horizontal plane. And as you see here, the technique is you simply project the point A and B towards the vertical and horizontal planes, and you get point A dash and B dash in the vertical plane and A and B in the horizontal plane, and A dash B dash we call as the front view and AB the top view. And one more extra thing which we see here are VT and HT. VT and HT are short forms for vertical and horizontal trace. What is vertical trace? The point where the line touches the vertical plane you call the vertical trace. The point where it touches or crosses the horizontal plane we call the horizontal trace. We actually have not covered this traces in the last session in line rotation method because it's much easier to visualize and understand the technique in plane rotation method. So let's start and see how we construct the projections using the plane rotation method. So the whole concept of plane rotation method is like we consider the true length, which is a line AB, this particular line AB, and the projection. We'll take each one by one. Say for example, if we take the first case, which is A dash B dash, so A dash B dash and capital AB together will form a plane, and similarly AB, capital AB and small ab, that is the true length and or the true original line and its projection on the horizontal plane AB, they together form another plane. So the method here is quite simple. To find the projections, we simply rotate these planes, these two planes, towards the corresponding sides. For example, in the case of this particular plane, which is the plane connecting capital AB, that is the original line, and this plan AB, we'll rotate this particular plane with respect to this line AB, which is the top view AB, and rotate it so that it falls onto the horizontal plane. Similarly, here it will be A dash B dash will be the line with respect to which this plane will be rotated, and it will be falling parallel to the vertical plane. So let's see that animation now. So now we can see that the plane containing capital AB and small ab, that particular plane has been rotated so that it falls onto the horizontal plane. So what do we get here? We get on the right hand side, if you see at the orthographic representation where you can see the XY line. XY line is nothing but the line joining the horizontal and the vertical planes. So this particular region, which is covering the true length, that is the true length here, the top view, they together are forming a triangular shape, or you can say it is kind of a it can even be called as a trapezium, in fact. So because there are two sides parallel and two sides are inclined, so we can even call it as a trapezium. But let's see, it's a plane. So this plane immediately is giving us a method to find out the projections, that is AB. In this case it is AB. Now let's proceed further and see how the other plane can be rotated. So here, so that's the other plane rotation. So let's see the animation once again. So that is the rotation on the horizontal plane, and if you proceed further, that's the rotation on the vertical plane. So here, two things we can see here, that is the distance. If you look very closely, this distance, the distance of from capital A to small a, is nothing but the distance from A to A1. What is A1 and B1? A1 and B1 are nothing but the line we get by when we rotate this particular plane containing A, B and small a, b towards the horizontal plane. That particular plane we mark separately by capital A1 and B1 and small a, b. So this A1, B1 is nothing but AB, which is rotated and made parallel to horizontal plane. So naturally this distance should be equal to this distance, and hence A1A will always be equal to capital AA, and B1B will be equal to capital BB. So this is one important observation we would like to make here. Similarly, one more observation which you can make when we look at the other side is that the distance AB, the distance capital A small a will be the same as the distance small a to the XY line, because it is nothing but this projection. This particular distance is nothing but the projection of this distance. Similarly, this small distance again will be equal to this distance, and for the other case it will be vice versa. This distance again should be equal to this distance, and this distance again should be equal to this distance by looking at the distances. Because this if we slightly go back and play the video, if you slightly go back and let's see how it is being rotated. So if you look here, this distance is nothing but this distance. So when this plane is being rotated and made to fall on the vertical plane, so you can very clearly see that this distance is nothing but this distance, and similarly this distance is nothing but this distance. So it will be much more clear in the when you play the remaining part of the video. If you look at the similar parts will be highlighted here. So that becomes quite clear. So the whole technique is much simpler to construct. So by now you would have understood how we would be constructing a problem like this. So if you know the one of the distances, for example the distance of point A from XY and point B from XY, we can easily construct this particular triangles, and finally find the true length. And what is the technique to find the horizontal and vertical trace? Simply extend the corresponding views. For example, if we extend the top view and the true length, where they meet will be the horizontal trace. And similarly, when we extend A dash B dash, which is the front view, and the true length in the front view, they together meet at the vertical trace. So VT and HT is found out, and when we project that VT to the XY line, we call it by the name V, and similarly when we project HT to the XY line, we call it by the name H dash. So they are nothing but the projections of VT and HT in the corresponding planes.